Hey everyone, grade 4, section 3, how to explain Excel solver report or interpretation of it. We can see the first thing, objective function, maximize 50A plus 60B plus 55C, subject to the first constraint A plus B plus C less than or equal 100, second constraint 2A plus 3b plus 2c less than or equal 300. Third constraint 2a plus 3b plus 2c greater than or equal 250. And the fourth constraint a plus 2c greater than or equal 60. And the non-negativity constraint a and b and c greater than or equal 0. This is the output of Excel solver to solve linear programming. It's called solver sensitivity report. This report divided two parts. The first part is for variable cells or objective function A and B and C, and second part for the constraint 1 and constraint 2 and 3 and 4. What is the required? The required is depend on the solution or the solver or sensitivity report. We can see 7 requirements that should be solved from the previous table. The first thing states the optimal solution. State the optimal solution from the table. So, how to solve it? So, if we see the first table, the final value here, this is the optimal solution for A and B and C. So the optimal solution is 0 and 70 and 30. So we can't produce anything from A and produce from 70 units from B and 30 units from C. So the optimal solution is under the final value in the first table. So the optimal solution is the final value in the first table. So we can't produce anything from A. So A equals 0, B equal 70, and C equal 30. Second requirement, what is the optimal objective function value? How to solve this requirement? We know from the first required the optimal solution is to produce 70 units from B and 30 units from C and 0 from A. We can substitute those values in the objective function. We know the objective function from the question is 50A plus 60B plus 55C. So 50 and multiplied by 0 because A is 0, the value of A is 0, plus 60 multiplied by 70 from B, and plus 55 multiplied by 30 instead of C. So the solution or the result will be 5,850. Third requirement, what would happen to the optimal solution if A and B and C? A, the unit profit of B decreased by 20. B, the unit profit on C decreased to 45. C, the unit profit on A and C changed to 53. Before we solve the third requirement, we should know what is the first table contain. contains? It contains a final value. As we know, we produce from B 70 and C 30 and 0 from A. We can't produce anything from A. And the objective coefficient, as we know, 50 A, 60 B, and 55 C. And we can see allowable increase and allowable decrease. For example, allowable increase from A is 70.5 and allowable decrease is 1E plus 30. E refers to infinity numbers. So in Excel, instead of write those numbers, we can substitute it in E. So the allowable decrease from A is 1E plus 30 and allowable increase from B 1E plus 30 and allowable decrease is 5. C allowable increase is 5 and allowable decrease is 15. So what does this mean? This means how much the objective coefficient can change before the optimal solution will change. So how much objective coefficient, for example, 50 or 60 or 55, can it change before the optimal solution 0, 70 and 30 it change. For example, since the allowable increase for A is 7.5, so if we increase the objective function coefficient A from 50 to any value up to the upper limit of 57 and 0.5, so the optimal solution will not change. Again, since the allowable increase is 7.5 and the objective coefficient is 50, so if we increase 50 to any value until the upper limit, 50 plus 7.5 equal 57.5, so the optimal value or the optimal solution 0 will not change. Return to the requirement, the third requirement. So what will happen to the optimal solution if the unit profit on B decrease by 20 or 20? We can see in the first table B, the objective coefficient is 60 and allowable increase is 1E plus 30 and allowable decrease is 5. So if we decrease B by 20, therefore the optimal solution will change if we decrease by 20. Why? Because the maximum allowable decrease on B is 5. So if we decrease B up to 5, it's okay. The optimal solution 70 doesn't change. But if we decrease B maximum than 5, the optimal solution will be changed. This is the third requirement A. Point B in the third requirement, if the unit profit on C decrease to 45. If the unit profit on C decrease to 45. We know the objective coefficient or unit profit for C is 55. If we decrease 55 to 45, what will it change? Is the optimal solution change or not? How to know? We first we know the allowable decrease on C is 15. So if we decrease the unit profit from 55 to 45, it's okay. It's a 10 decrease. and the allowable decrease is 15, so it's okay to decrease and the optimal solution will not change. But how to prove it? We can substitute the unit profit on C in the objective function. Instead of 50 multiplied by 30, we can write 45 multiplied by 30 plus 60 multiplied by 70 plus 50 multiplied by 0. So the optimal solution will equal 5550. So this optimal solution, it's okay, because as we know, the first optimal solution is 5850, so it's optimal. So this new solution, or this new optimal solution, inside the boundaries of the first optimal solution, so it's okay, and decrease the unit profit on C from 55 to 45 will not change the optimal solution. Point C in the third requirement: if the unit profits on A and C change to 53. If the unit profits on A and C change to 53. This is called simultaneous change. The first thing we should know 100 rule. This is rule in simply if the proposed change divided by allowable change is less than or equal 100%, it's okay. The change will not change the optimal solution. But if the proposed change divided by allowable change greater than or equal 100, so the optimal change will change by the change the unit's profits. How? The unit profit on A, first the unit profit on A will change to 53. We know the unit profit of A is 50, will change to 53, so the proposed change is 3. The 53 minus 50 is 3 divided by allowable change. The allowable change, as we see, is 7.5. So 3 divided by 7.5 equal 0.4 plus the proposed change on C. We know the unit profit or objective coefficient on C is 55. So from 55 to 53 is 2. 2, the change is 2. 2 divided by 15. What is 15? 15 is the allowable decrease. Allowable decrease is 15. So equal 0.133. So 0.4 plus 0.133 equal 53.3%. So 53 is less than 100. So the optimal solution will not change and remain optimal if the unit profit on A and C it changed to 53. But if this percent is greater than 100, the optimal solution will change. We also can prove the solution by substitute in the objective function 53a plus 60b plus 53c equal 53 multiplied by 0 plus 60 multiplied by 70 plus 53 multiplied by 30. So the optimal solution will be 5790. So this is remain under or inside the boundaries the optimal solution. So the change the units profit on A and C to 53 will not change the optimal solution. Required for interpret or explain the reduced cost for A. We see in the first table the reduced cost for A is minus 7.5. What does mean? This mean if if we produce 1 unit from A, the amount of profit will be reduced by 7.5. So the reduced cost of minus 7.5 here represents the amount of by which profit will be reduced if we include 1 unit of A in the optimal solution. So if we produce 1 unit from A instead of 0, the profit will decrease by $7.5. For more explanation, product A is not attracting enough profit to include in the product mix. To include product A or to make A positive instead of 0, its profit contribution needs to improve by least 7.5. But its current case or current value of 50, as we know, the coefficient or objective coefficient or unit profit from A is 50. Making A positive in the optimal solution instead of 0 will reduce the optimal solution by $7.5. So if we need include A or produce any units from A in the solution, at least instead of 50, it should be 57.5 at least to include in the optimal solution. Requirement 5. What would happen to the objective function if A, the right hand side of constraint 1 increased by 5, B, the right hand side of constraint 2 decreased to 250, C, the right hand side of constraint 4 it changed to 44. We see in the second table of output of linear programming solution or solver the allowable increase for each constraint and allowable decrease for each constraint. For example, the first constraint, the right hand side is 100 and allowable increase is 10, so 100 plus 10, so upper limit is 110 and lower limit is 100 minus 6.667 is 93.33. We also see the shadow price. What is mean shadow price? Shadow price is a change in the unit profit per unit or the change in the profit per unit by increase in the right hand side by one unit. So if the right hand side for A, for example, constraint 1 is increased 1 unit from 100 to 100 or 101, the unit profit will increase by $60. For more explanation, we can see in the requirement 5, if the right hand side of constraint 1 increased by 5, so we see the constraint 1, the allowable increase is 10, so increase the constraint 1 by 5, it's okay because it's inside the boundaries of allowable increase. So how this change the profit? 5. So the change in the profit 5 multiplied by 6. 6 is the shadow price for the constraint 1. So the optimal solution will increase by 300. We know that from the first requirement in this problem, the optimal solution is 5,850 plus 300, so it will be equal 6,150. This is the new profit if we change the right hand side for constraint 1 from 100 to 100.5, so the profit will increase by 300. So the new profit or new optimal solution will be 6,150. B requirement B and the requirements. If the right hand side of constraint 2 decrease to 250, we know the constraint 2, the right hand side is equal 300 and the allowable decrease is 30. So if we decrease it the right hand side from 300 to 250, so the proposed decrease or exchange will be 50. 50 is greater than the 30 that represents the allowable decrease. So it's not okay. So we need to resolve the model, all the model again. C. If the right hand side of constraint 4 changes to 44, we know the right hand side of constraint 4 is 60. So if we change from 60 to 44, it will be equal minus 16. For this, the new constraint hand side will equal 44 minus the old constraint right hand side 60. It will be equal minus 16. So the change in profit will equal minus 16 multiplied by shadow price. Shadow price here is equal minus 2.5. So the change in the profit will equal 40. So 40 plus the old optimal solution, it will be equal 5,890. So the old profit is 5,850 plus the new change in profit that will equal 40. So the new profit will equal 5,890. And the end, the last requirements. 6. What are the slack and surplus values? And 7. Which constraints are binding? We see in table 2 in the solvable solution, constraint 1, the final value is 100 and the right hand side is 100, so there is no slack, so the slack is equal 0. Constraint 2, final value is 270 and the right hand side constraint yes is 300, so the difference is represent slack by 30. Third constraint, the final solution or final value is 270 and the right hand side constraint is 250, so the difference is represent a surplus by 20. The last constraint 4, the final value is 60 and the right hand side is 60, so the surplus is equal 0. There is no surplus. But how we know this is slack or this is surplus? If the constraint is less than or equal, this is represent slack. If the constraint represent greater than or equal, the difference represent the surplus. So the binding constraint in slack or surplus, that will equal 0. So the constraint 1 is binding, and constraint 4 also binding, and constraint 2 and 3 is non-binding. Constraint 2 and 3 is non-binding.